As the Royal Navy looks beyond the 2030s, its future surface warfare capability is anchored by what is currently known as the Type 83 destroyer. Designed to replace the Type 45 Deering class, the Type 83 is envisioned as the highly automated and heavily armed centerpiece of a broader future air dominance system. The Royal Navy wants the ship to be able to defeat tomorrow's most complex threats, ranging from hypersonic weapons to massive drone swarms. To achieve this, the ship leverages directed energy weapons, data networks, and artificial intelligence. We will now explore the specific proposed features of the Type 83 and analyze three potential design concepts currently being debated within the Royal Navy. Currently, the air defense shield that protects the fleet is the Type 45 Deering-class destroyer. Entering service in 2009, the 6 ships were designed around the Sea Viper anti-air missile system and the towering Samson radar. They are formidable vessels. Recently, they have proven their worth in the Red Sea, intercepting attack drones and missile barrages. However, the class has suffered from well-documented propulsion issues, requiring a complex power improvement project to replace part of their powertrain and to ensure reliability. More importantly, the nature of naval warfare is changing at a blinding pace. The proliferation of hypersonic weapons, massive drone swarms, and ever-evolving electronic warfare means that the Type 45 class will eventually face threats it was simply never designed to defeat. With the Deering class expected to begin retiring in the late 2030s, the Royal Navy is already looking to the future. That future is currently known as the Type 83. The Type 83 is designed as the physical centerpiece of a broader concept known as the Future Air Dominance System. The Future Air Dominance System is a system of systems. Instead of relying solely on one single ship's radar and missile magazine, this network will link the Type 83 with a vast array of other assets. This includes high-altitude, unmanned aerial vehicles, space-based surveillance satellites, uncrewed surface vessels, and fifth-generation fighter aircraft like the F-35B. The Type 83 will act as the anchor of this massive network. It will digest staggering amounts of data from across hundreds of miles of battle space, filtering out the noise and coordinating the carrier strike group's response. At the heart of its offensive and defensive power will be a Mark 41 vertical launching system. Current industry proposals suggest a capacity of between 72 and 128 vertical launch cells. This is a significant and necessary increase over the 48 VLS cells found on the Type 45 class. The Mark 41 system provides high tactical flexibility above and beyond the French-designed silver VLS found on the Type 45. It allows the ship to carry a highly varied mix of weapons, from air defense interceptors like the Standard Missile 6 to strike weapons like the Tomahawk cruise missile. However, recent combat experience have proven that shooting down cheap, mass-produced drones with multi-million-pound interceptors is economically unsustainable. To counter the growing threat of drone swarms, the Type 83 will feature directed energy weapons. High-energy lasers will provide a practically unlimited magazine for countering uncrewed aerial threat. The cost per shot of a laser is essentially just the cost of the electricity to fire it. As long as the ship has the fuel to generate power, it can keep burning drones out of the sky. Alongside these lasers, the ship will feature advanced counter-fast attack craft systems. These will likely incorporate rapid-firing 30mm automatic cannons integrated directly with the precise electro-optical targeting sights to track and destroy small, fast-moving surface threats like unmanned surface vehicles. To see the enemy in a highly cluttered environment, the Type 83 will feature an integrated radar mast hosting multi-band, multi-mode sensors. These flat, active, electronically scanned array radar panels will be built flush directly into the superstructure of the ship. This setup offers simultaneous search, track, and fire control capabilities across different radar frequencies, making it difficult for enemy aircraft to jam or evade detection. If an incoming missile does manage to slip past the sensors and the outer layer of interceptors, the ship will rely on self-kill decoy launchers. These survival systems will deploy radar-reflecting chaff, hot infrared flares, and active off-board decoys that fly away from the ship, emoting false electronic signatures to seduce incoming missiles into the empty ocean. Managing all of these complex sensors and weapons in a combat scenario is rapidly moving beyond the limits of human cognition. Therefore, the Type 83 will heavily utilize artificial intelligence and machine learning to aid its force threat evaluation and weapon assignment functionality. The artificial intelligence will quickly analyze the incoming data on the incoming enemy. It will prioritize the most dangerous targets and automatically recommend the most efficient weapon to destroy each specific threat. The human commander remains in control to authorize the launch, but the machine handles the overwhelming data processing of modern naval combat. The Royal Navy, like many Western navies, faces challenges with recruitment and retention. Consequently, the Type 83 will feature high levels of automation to drastically reduce the required crew size. While the Type 45 class requires a standard crew of around 190 sailors, the Type 83 will aim to operate with far fewer personnel. It will achieve this by relying on robotic damage control systems, automated ammunition handling, and digital maintenance monitoring that tells the crew exactly when a part needs replacing before it actually breaks. Finally, powering an integrated mast and firing directed energy weapons creates massive, sudden spikes in electrical demand. The ship will require an advanced power management and propulsion system able to support high levels of dynamic demand. This requires an integrated electric propulsion layout that can instantly route vast amounts of electricity from the powertrain directly to the lasers or the radar panels exactly when combat system demands it. Delivering all of these ambitious and incredibly demanding requirements is a massive engineering challenge. The Royal Navy and its industry partners are currently in the concept phase, exploring different naval architectures to see what is physically and financially possible. There are 3 distinct design concepts currently emerging in defense circles. I will now discuss what these 3 concepts are and the strategic pros and cons of each approach. The first concept is the arsenal ship. The idea of a heavily armed, missile-dense vessel originally gained traction in the United States Navy back in the 1990s. However, it has recently resurfaced in UK naval think tanks and academic discussions as a radical, asymmetric solution to the fleet's firepower deficit. The design is essentially a large, heavily armed warship stuffed completely full of vertical launching system cells. Instead of carrying its own massive, expensive radar mast and complex combat systems, the arsenal ship acts mainly as a floating magazine. It relies almost entirely on the StrikeNet command and control network and the future air dominance system to provide targeting data from other ships, drones, or fighter jets. The advantage of the arsenal ship is that it offers unmatched magazine depth for a relatively low platform cost. A single ship could carry hundreds of land attack cruise missiles and air defense interceptors, providing enough brute force to completely overwhelm enemy air defenses or sustain a long-duration air defense mission without needing to resupply. The hull itself is cheap and fast to build because it lacks complex, bespoke sensors. However, the disadvantages are severe and risky. By stripping away organic sensors, the ship is highly vulnerable if the communication network is jammed or degraded by a sophisticated enemy. If StrikeNet goes down, the arsenal ship becomes completely blind and practically useless. Furthermore, while the hull is cheap, a ship loaded with 150 advanced missiles represents a massive concentration of financial and military value. Losing one arsenal ship to a submarine torpedo would be a catastrophic blow to the fleet. The second design is the cruiser concept. This information largely originates from the concept imagery released by major defense contractors, alongside observations of current global naval trends. We are actively seeing competitors build massive surface combatants, such as the Chinese Type 055 class or the evolving American Trump-class battleship. The cruiser concept envisions a vessel displacing well over 10,000 tons. This design makes no compromises. It houses a massive 128-cell vertical launching system, towering integrated radar mast to see further, and the enormous gas turbine engines required to power multiple directed energy weapons without slowing the ship down. The primary advantage of the cruiser concept is survivability and overwhelming capability. It generates enough raw electrical power to run the most advanced radars and lasers continuously, and it possesses the spacious command and control facilities required to act as a flagship for a task force. The disadvantage, quite simply, is the immense financial cost. Building a 12,000-ton conventional cruiser packed with bespoke technology is brutally expensive. Given the strict realities of the UK defence budget, pursuing this maximalist concept might mean the Royal Navy could only afford to build 3 or maybe 4 vessels in total. A fleet that small simply cannot maintain a meaningful global presence, no matter how capable the individual ships might be. A ship can still only be in one place at one time. The third concept is an air warfare variant of the Type 26 global combat ship. This idea originates directly from industry proposals aiming to offer the Ministry of Defense a lower cost, cost-effective pathway to replacing the Type 45 class. The Royal Navy is already currently building the Type 26 City class, which is an anti-submarine warfare frigate. This specific proposal suggests taking the existing Type 26 engineering blueprint, removing the specialized submarine hunting equipment and acoustic dampening features, and replacing that with air defense sensors in a larger block of Mark 41 vertical launching system equipped with the best air defense missiles. The advantages of this approach are heavily rooted in economics. By using a mature existing design, the Royal Navy immediately saves billions of pounds in research and development. It also speeds up production timelines, as the shipyards already know exactly how to build the hull. Furthermore, operating a future fleet built on a common hull design drastically simplifies crew training, spare parts procurement, and maintenance. However, the disadvantages stem from the harsh limits of naval architecture. The Type 26 hull, displacing around 8,000 tons, was simply not designed to carry an even larger integrated mast than what it's already carrying, or to accommodate the electricity generation required by directed energy weapons. Trying to squeeze up to 100 plus vertical launch cells and gigantic radar panels onto a frigate's hull, even a large one at that, might result in a ship that is dangerously top-heavy, tightly cramped, and unable to take on future upgrades. It is ultimately a compromised design that sacrifices some capability and future growth potential in the name of affordability and standardization. As the Royal Navy navigates the 21st century, the choices made regarding the Type 83 will fundamentally shape British sea power for decades to come. The future fleets must balance the high technology demands of modern naval warfare against the very real limits of the national treasury. Whether the Admiralty ultimately chooses the overwhelming magazine depth of the arsenal ship, the dominance of the heavy cruiser, or the pragmatic efficiency of the Type 26 variant, one thing is certain. The Type 83 will not be a simple one-for-one replacement for the Daring class, but a radically different destroyer altogether.